Here we are. Mm, yep, I'm in the stream. I can mute myself if you want to ask a question. All right. We can certainly do that. Back on. Cool. All right. So, how's everyone doing today? So, today we're probably going to look at Dagster. But before I hop on over to that, let me share my screen. How do I do this actually? Move that over there. Share screen. Here we go. Entire screen. Boom. There we go. Cool, 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 cool. Let's see. So yesterday I was fiddling around with pipelines. I think I didn't completely botch it. These are just our CI/CD pipelines. Um, and before the stream started, my browser crashed, which happens quite often. Linux. So let me open up a new session, and guess what? I'm not gonna restore everything. Where am I? Let me do it anyways. So this is everywhere. Latest, you can see the pipeline has multiple stages, a lot more than we used to have, and they're all more or less passing. And then we have this external UI test stage. This is one thing that this is by Chromatics, so we don't really have to worry about that. There are a couple of things that are suboptimal about this pipeline. Um, okay, so this is like we have to review that. That's something I can ask Stefano to do. Um, but yeah, there are a couple of things suboptimal about a pipeline. I'll show you what these are before we completely dive into the Dagster scope. Oh, this is kind of cool. Let's reload this. Let's see what that looks like. Okay, so we now there's something off in these lines. They don't completely make sense. I guess this is the dependency over there, but it feels like it crosses through this. That's not what they're trying to tell us. And then this one depends on that task. So there is certain ordering there. So I guess that's fine. What we want to figure out, some of these jobs take very long to complete. And I'm going to close everything to the right. And maybe, snap, that was the wrong one. Actually, maybe I can close it. There we go. So reload. Get the camera up right. And Lee, for everything you want me to drop in the laundry, just bring them down and I'll take care of it. Cool. All right. So this is our chosen one. Let's give a quick glance. Chosen one. So here, install npm packages. We're gonna check code, test and track coverage, upload coverage to CodeCov, right? Right. So this thing takes 31 seconds to set up the Docker machine executor. Then we prepare environment, source, Git repository, all of this stuff pretty lean. Then restoring cache. What the hell? Looks pretty heavy. Um, then executing step script stage of the job script. So running the script takes a lot of time. Saving cache. Why do we save cache, right? Now that's the question. We don't need the cache there. So maybe we should skip that. I think we have the same thing here. Saving cache for successful job, 43 seconds. Here again, saving cache for successful job, 1 minute. What is that? So, and then CodeCov, saving cache. Like, why would the job that does CodeCov things need to save the cache? So there's something we're doing wrong. GitLab, and what is it? And ci.yaml. And we probably have something in the search results, or basically what we have on the reference page, we can probably figure out why this whole cache maybe standard caching behavior. So if we go back to this, we basically say we just want to pull. Maybe that's the best way to start. The pull part happens up top. We're storing cache. Arguably, we don't always need it. So what we can do, for example, installing npm packages. Do I need the cache there? Probably yes, so that's fine. And checking code, I do need the cache there. Or actually, I could even ship the packages as artifacts. Which one is faster? Downloading artifacts. Let's see, artifacts. I have the coverage artifacts, and the cache is different. Let's just keep the cache, right? Upload to the code gov. We don't need custom track coverage. We need to wait for that to complete, but the cache can be empty. See if that is something that exists even. Need specify an empty cache. Contract. Unprotect cache one. Let's see the cache. Okay, so this is not completely clear. Back up. Can we specify empty cache? Check where we are. Unfold checking in. All right. All right, here we go. Introduce certain pipelines. You can disable caching for a job, for example, to override a default cache. To override a default cache defined with default. The configuration for a job added with one. Let me just look at disable caching for a specific job. Not. There we go. Job cache. There we go. So that's fine. We don't need a cache there. Allow failure. Fair enough. We use the cache here. Build Next.js. Okay, so for the npm install stage, it only happens when the cache has been. When we run this, it should have only happened when the Docker file or the package lock JSON changes. But that was a little too messy to set up, or a bunch of like job dependencies that the GitLab CI tool couldn't resolve. So this was being over-engineered. So we're dropping that. But what we are doing here, we're basically saying key. How can we specify that? Maybe we can specify a key that has a name. Key files, and then we have paths that we cache, right? Paste in. What if we do this, huh? If we do this, it's a bit verbose. All right, here we go. Here we go. Cache key files. That's the package lock is the only one we really look at. And then the paths that we update are this and that. And the policy is just a push policy. We'll push maybe. See what they say. To change the upload and download behavior of cache is the cache policy keyword. By default, the job downloads the cache when the job starts and uploads the changes to the cache when the job ends. This caching style is pull push by default. To set a job to only download a cache when the job starts but never upload. All right. So to only to upload a cache when the job finishes, but never download. Yeah, that's fine. Now let's see how they have some examples. Like here we have a push. What do we do? The key is what? Gems. Why? This always runs. I think something is off with the key. Right? We don't understand it well enough. So we go back to key. There we go. This basic key. Here's a key here where give each cache a unique identifying key. All jobs use the same cache key. All jobs that use the same cache key use the same cache. Fair enough, including in different pipelines. Fair enough. If not set, the default key is default all jobs with the cache keyword, but no cache key. Share the default cache. Okay, must be used with the cache paths or nothing is cached. Fine. Keyword type. Possible inputs: a string, a predefined CI/CD variable, combination of both. Fair enough. The key there is just that, but maybe you want to specify file. Generate a new key when one of the two specific files change. One or two. One or two? Why is it one or two? It's awfully specific. Can't it be three then? Cache key files let you reuse some caches and build them less often, which speeds up the subsequent pipeline runs. All right. So when one of these file changes, a new cache key is computed and a new cache is created. Any future job runs that use the same gem file lock and package JSON with cache key files use the new cache instead of rebuilding it. Okay, fair enough. So this is good. The command we run here is already leaner because it's cache aware. We'll probably set up the key. Now let's just do pull push, right? That's what we probably have to do. We probably don't have to specify the policy. Let's pull push. So now we know that all the packages just pull the cache. No one pushes. This is the only one pushing to this particular cache by this key code. And then we just pull the cache. This one, test and track coverage, pulls the cache. Upload the code cuff, doesn't pull the cache. Test end-to-end playwright, probably does pull the cache. But that's going to run this thing for playwright. Maybe we need to populate a different cache for this. So the playwright binaries aren't always retrieved. It's something we can verify, right? Let's go to our pipeline. Let's see what we did here. NPM block, right? Some stuff that we're retrieving. 2 minutes 9. Oh snap, that's a heavy one. That's a pretty heavy one. But we also ran the tests in here, so it's not completely fair. Can we tell how long each one of these things took? Not quite. I don't think we can really tell. We can shave off the 1 minute 45 thing, right? That's already a big win. And build Next.js app. This one uses the cache. And build and deploy storybook. I guess NPX chromatics. This one may use the cache. Fair enough. Let's just save this. We're going to call this task, which is basically going to say like for limit cache updates to npm install job only. My little camera is kind of like in front of the screen. Whatever, it works. What else are we doing? Limit cache pushes. npm install jobs only. Right? What else did we do? remove the cache download for CodeCuff job, but that's a minor thing. Minor is big. All right, let's push that. Cool. And it's pretty light up here, so we may switch that as well. And then we are going to do something else now. I feel that with this, we should have a pipeline spinning up. Probably going to spend a little less time than usual. At least that's what we're hoping. Let's see how quickly we can get this to complete. I open this in a new tab. Maybe I can look at that. So this one pulls up the cache. It's also still in the prepare Docker machine executor stage. All right. Cool. Let's see what's going on here. We're still good. Cool. So the next thing we're doing, as promised, we're going to look into Dagster. Cloud-native orchestration of data pipelines. We read about Dagster versus Airflow, right? And give me nodes and there you go. What are we going to learn about that? See Airflow and temporal. Look into that. Orchestration, right? Pipeline orchestration. Yeah. Well, this look like manage your data assets with code. Some beautiful Python stuff. Counter stats to data frame. Read something from a website, or read something from a URL. Define which columns are in there. Do some computation. Or no, you basically pick up some information in there. Pop change, you just modify population change by converting it to a float. That's what they're doing. It's country stats, that's how we get them. Then, for example, there's this other asset change model. What does that do? Country stats takes country stats data frame and returns a regression. What does that mean for them? Just it fits a regression model based on this data set where what continent is in here already. So you grab that and then, all right, basically train a regression model for continents to kind of like predict population change for every continent you train. Okay, something like that. Okay, what does get dummies do actually? That function I haven't seen. All right, whatever. Continent stats. What is that now? Country stats, data frame, change model regression, blah, blah, result, country group by continent. And I have to just hop into my calendar real quick. I know I have a call. Okay, I have a call tomorrow with Marcel and with Itcham. Perfect. Nothing today that's conflicting with the stream. Go. All right, so this is kind of like what you can see, the DBT native orchestration. Also here we're kind of like load assets from DBT project. Yep. Cool. That's just transformations mostly, as far as I remember. DBT. Do I have like a node point on DBT? Not yet. Okay. Well, I probably should have something on that. It's kind of weird that I don't have anything on this yet. Okay. We did write about it once. Didn't build this out. Workflow orchestration, prefect. Do I have anything on prefect? Let's look at prefect. Very minimal. What was that? right here. All right. Well, workflow orchestration, nothing meaningful. And again, pipeline orchestration. These things are kind of like a variable. And then we have task-based workflows, find still tables, single pane of glass for your data platform. Integrations, many. Migrating Breeze, build a GitHub support bot with GPT-3, LangChain, and Python. LangChain is something we looked at in one of our previous streams. Oh, so there's plenty for us to play around with. Right? Pete Hunt. Seen many articles by Pete Hunt. Also, I think I bookmarked something to watch. Not here. I think. Oh, there's a video on YouTube that I wanted to check out. All right, so we're gonna do that. YouTube.com. Let's see. Maybe I need to play that here. Okay, here. YouTube.com. No, that doesn't work. I have YouTube. Right. And then Baxter. Oh, that's not it. I saw something that looked like the Daxter web page, but that was just something else. There we go. Dennis Hume crash course. Here we go. Okay, so let me play this and spin up powerful control. It's over. Ah, sweet. Now you can hear it.
We have a little README describing the project, linking to the documentation. We've got our normal kind of Python setup.py where we list all the dependencies that we need. This workspace.yaml tells Dagster when we run it locally where to find it.
All right.
Hi, I'm Pete. I work on Dagster, and today I'm going to take you through a quick crash course on how to build an ETL pipeline with Dagster. This is a companion video to a blog post that we wrote. You can go check it out here to get some additional context and links to various documentation. If you want to just skip straight to the code, the completed code is available here at this GitHub repo. And finally, as we go along, I'm going to be using an in-browser editor called Gitpod and starting from scratch and then building it up from there. So you can just go here to get started with that. It's free.
Come on, internet.
Just getting spun up with the environment very easy. Just to set the context here, we're going to create this report and store it in GitHub Gist. This is going to be created from an IPython notebook, and it's going to visualize GitHub stars over time for the Dagster repo. So we're going to use the Dagster API, the GitHub API, and Dagster software-defined assets and the Jupyter API to do all this. So to get started, I've got this cloud development environment here. It's using a service called Gitpod. There's a link in the blog post. It's a free cloud development environment that guarantees a pretty stable and specific Python version. You can use whatever Python environment you want. Dagster works on Mac, Linux, and Windows, but I'm just going to use this for consistency. So the first thing we're going to do is pip install Dagster. This installs our command line tools that help you scaffold out a project.
All right, let's figure out how to get an environment ready. So the crash course. Let's do this first, yeah. What does Dagster do? Feature store, model training, model inference, styles, all of this stuff you can do, fair enough. Production database, Bob. Think of Dagster as a framework for building data pipelines, similar to how Django is a framework for building web apps. Cool. Produce data assets. Data assets can be many things. They're usually machine learning models, tables, and data or a report. In order to build data assets, you basically need to do 4 things. Ingest data from external sources. Fair enough. Combine and transform data in a meaningful way. Store the asset in a place where it can be used. Rerun this process incrementally whenever the asset is out of date, either on a schedule or whenever an external system triggers to run. Fair enough. I like that they're so specific. There are tons of tools that can do these things. Why I choose Dagster. Dagster is for a particular type of user and has several unique differentiators that make it a great choice to sit at the center of your data platform or for both new and existing data pipelines. So which tools would you probably know for these things? If you're doing like event-based junk, probably using Kafka, Apache Kafka, or you're doing something with like Spark, which is another tool, but there's so much plumbing you have to take care of yourself. And then you can use Airflow, or you can use Prefect, or you can use, have your pick. There are a bunch of tools out there. Baxter keeps popping up as a very user-friendly one, and I've played with Airflow, I've played with Spark, I've played with Kafka. I haven't played with Prefect. I roughly have an idea of what it does. I'm just getting my hands dirty with some of the tools to get a feel for how convenient it is and how challenging it may be to use it at scale. So yeah, here it goes. Ideal user, data engineers, ML engineers. Well, this is going to be us, right? Infra engineers, application concepts. Probably not for, yeah. Dagster is meant for data engineers and machine learning engineers. These are people that are software engineers, know languages like Python, SQL, knee deep in data, bridge engineering and data worlds, frequently required to work in both infrastructure, managing resources, developing production services, as well as in the data domain. Respect the complexity of the data domain. Data engineers know that building a data app is a complex problem that requires sharp tools to manage. So how is Dagster different? Well, 3 differentiators that make it better than alternatives: local development and testing. It's kind of cool. Kind of like hackathon friendly. Software-defined assets. Dagster primary abstraction is the SDA. This is something I put in a note. SDA. SDA. Software-defined asset. And you generally find the declarative mental model of SDA much easier to work with, as they unambiguously document which assets are meant to exist. All right, cool. Let me do one thing before I continue reading. I often meshing, it's conflicting with, I'm pretty sure it's conflicting with the stream. Let me try to go back here. Research. Let's see if the stream is actually working. There's actually audio here. How do you go? This is wrong. This is not it. No, this is not what I wanted. And then let's see if we can hear anything. Okay, so there's audio. I shouldn't worry. Not my problem for now. This. I have to check in on someone. They're not doing too well, I believe. Also, distraction alert. Status on Reddit. Just have to go check it out. It's not working. It's fun. You have to start going and look at it whenever you're. It's fascinating. Like, you capture people, capture attention away from something. But this quick guide. Blah, blah, blah. I don't understand what it does. Oh, this is kind of cool. Some completion stuff. Blind Journal. It's Pummel. That's kind of cool. This is really cool. I really like this. I somehow really like this. For later distraction. Rainy and I were going to go to a cafe in a bit to work from there, but I decided to do this streaming from home because that is a bit of a controlled environment, so things don't have to be too noisy for y'all or for my future self, whoever is watching this. Go. I got a heart from Dagster. That's dope. Dagster, sweet. All right, see, I'm already even more inclined to use this. That's how to get you. That's how they get you. Okay, so back to the topic again. Declarative mental model. I like declarative SDAs. Unambiguously document which assets are meant to exist. Absolutely. And let me put a sock on the foot. I kind of like cut my foot recently. I have a plaster on it, but it's kind of cold in the room, so I just need to put the socks on to be comfortably warm. Yeah, Lainey thinks it's a good job I'm doing. Go, go, go. Lainey, are you still going downstairs? All right, cool. All right, so a little bit of distraction, right? We can all use some of that once in a while. The StreamYard. All right, here we go. Let's see if I can do this. Oh, here we go. So you can see downstairs we have like a track. That's where I do my morning jogs, interval training, or I hit the pool. So today I hit the pool, and Lainey's going down into the sun. And she's gonna take my sneakers with her because this idiot stepped into some weird gunk yesterday. So I had to drop snakes into the washing machine, and it kind of like still moist. So we have to get sun to the job. So yeah, that's why I'm constantly asking for Lainey. She's going down because this thing needs more sun time while I am doing the stream. Yeah, it's okay. No pressure. No pressure. And my throat is still kind of like fucked because I don't know. I think I had a bit of a flu-ish type of episode after I cut the foot, some resistance junk. So my voice isn't really my singing voice. Anyway. Now enough distraction. I had coffee all day, so imagine. This is why I'm so dysfunctional right now. Okay, so the unambiguously document. That's the nice thing about declarative stuff, right? Fine-grained data lineage to make debugging and understanding the state of an asset easy. Decouple business logic for computing the asset value from the IO logic. So okay, cool. The computation, so the reading of the data or writing of the data is separate from business logic, where you kind of compute whatever is relevant to you. Okay, cool. I can understand. Yeah. Can be important from any tool in your stack. So external tools like DBT can create multiple tables in a warehouse. That's going to track the lineage of every individual table. Okay, I don't understand this part yet. What does this mean? Let's try to read it again. Any tool in okay. Maybe it becomes clear from reading onwards. Rich searchable metadata and grouping tools to support scaling to large complex organizations, time partitioning and backfills out of the box. It's right up here, so it shouldn't be back data. Okay. All right, should be fine. Of course, it's down. Now, I have full bars with connectivity here. It's tricky. Huh. Okay. Maybe streaming from home doesn't work after all. Maybe the cafes have better internet. I don't know. I'm just trying different things. Let's see if someday we get it. Finally, we're going to calculate upload speeds. I think it should be fine. Could also be that certain traffic is prioritized over others. All right. This is a journey. This is a model. Model has done this chunk. I'm guessing it does look a little machine-like. It's kind of cool. Cool. Uploading pipelines from the environment was built from the ground up to abstract away the environment from this large kind of pipeline, just to a number of elegant capabilities. Through clunky or non-existing another orchestration, staging and testing the environment is so much easier to set up by swapping out external services. Okay, underlying runtime can be swapped out without changing any user code. All right. Built with containers in mind from day one. Yay. So you don't have to deal with pip hell, managing conflicting Python environments so much fun. Yay. Getting started with Dagster. That's the video we were just starting with. Let's build a quick realistic example that pulls something from GitHub and visualizes it. This example is an example of an ETL pipeline. GitHub star somewhere. Count by week. Visualize the notebook. Upload as a gist. Yeah. So what? The GitHub stars tell us. Okay. You may follow along with the tutorial. Okay, that's one thing. But then we start with pip install. So now we're dealing with environment. Pip in, like pip hell, it's scratched out. So let's figure out how to do this inside of Dagster. Let's see the code. Ah, come on. Git pod. Fair enough. Well, what we're going to do, we're probably going to spin up a Python environment inside of GitHub and inside of Docker and just do something with it there. But we're lazy, so just do that. Let's do a fresh Git pod environment. Let's follow along. About learning. Yep, authorize. Everyone, you're gonna watch me do some VS Code, whatever, whatever. Choose the editor. Yeah, I'll pick VS Code. Oh, just the editor for open workspaces. The browser, right? Yeah, continue. Maybe make this a bit larger. I'm not a VS Code user, so I struggle. Yeah, no, I don't care. I don't care. Crap. You want to open the from the beginning? No, I don't. I don't think it's desktop. I don't care for it. Does it feel so weird and clunky with the mouse? Yeah. I'm gonna switch between this and that. Anyway. I'm shite. I don't even know what it is. Which gem? Fucking hell. So much installed in this thing already. Convenient in a way. T. So that isn't there. Which GHCI. So it's not looking to serve Scala and Haskell folks, but you do have to make, obviously. right, this is not what we're doing, hey? So Daxter needed the Daxter project scaffold. My Daxter project. I hope I don't have to do anything. Oh, it's just going to be learning, interactive learning. By the way, I'm thinking of doing a talk at a big developer conference in Berlin, and I'm probably doing one where I'll be nerding out about my learnings during my streams. The sessions that I have with other people hopping in and schooling me, which are the best streams. I feel like when Cuss came in, explained some stuff about Agda, or when Domin was writing Haskell live, or when I was kind of like trying to figure out my Xmodal config and fearfully opened up my editor to write some Haskell to try to fix it, and actually cracking it within the stream. Like those are little wins that happen rarely. Most of the developer experience is just anguish, torture, and failure. All that we did, Daxter project stuff with me, but Daxter. We just do it exactly the same way. We don't want to introduce changes. So we're now scaffolding the project. And we reinsert the main. Holy shit. We started inside of a repo, didn't even realize that. Okay. Of course. All right, so let's go to my Daxter project. Let's see what our Rust equivalents to old Linux utils. What did you write for us there, my friend? And this is Daxter. Oh, actually, I probably do README. This should work. I do know enough about VS Code-ish. So Daxter project scaffold with Daxter project scaffold. Yeah, getting started. First, install your Daxter code location as a Python package. Install your Daxter code location as a Python package. What the fuck? By using the editable flag, people will install your Python package in editable mode. So as you develop, local change will automatically apply. I don't understand that. Hit install. All right. So is that what this person does? Okay. So weird. Okay. Okay. What we're doing here is going to be a Python package eventually. Fair enough. Adding a Python dependency. Some sensors. All right. Okay, so we need to figure out, that's one thing I put on my list of questions. Figure out what a schedule is, figure out what a sensor is. I'll do that, don't worry about it. Hot? So okay, cool. Let me do a translation run. Right, it's errands time, people. Let me do some quick errands for like a few seconds and I'll be right back. Elevator music's going to be cued. Imagine if I had that somewhere in the future. Taking a tiny break, probably muting myself. Here's Lainey getting ready. All right. And I'm just going to turn this one over so there's a bit of a view. Well, I am doing, I don't know, whatever. I shouldn't try to make this interesting. I should just come back quickly. Be right back. horrible when you have like people in the Sales Navigator conversations and you connect the conversations Sales Navigator don't automatically convert into regular conversations. Anyways, here, look at this. This thing works. This thing works. So we kind of like walk through the entire tutorial. We have the same thing. Our current example is working great. There's several issues. Token is present in the source code in clear text. We don't have that actually because we already fixed it. We have no tests. All right, so I want to know how to do the tests. So handling secrets the right way, config and resources. First thing you need to do is get the GitHub access token out of the source code. We'll provide a secret via an environment variable and use Dagster resource to connect to GitHub. All right, cool. I like that. I like that idea. So let me ping Lainey to see how much time she still wants to spend out there so I don't commit on diving into a new rabbit hole when I maybe should be getting ready to head out. For hanging out there a bit longer, or do you want to grab some food? There are plenty of lovely places to work. There is a cafe slash more co-working themed space that we haven't been to for a while. I don't know if it's called Blend Station. Yeah, Blend Station. That's the one. Maybe we go to that one. That's a lovely location. I would actually enjoy working from there. Double check where they are on the map. Cool, cool, cool. That would be a good, how long? Let me see directions. 30-minute walk. All right, so Leanie's got a text. I think she's gonna respond to that soon. I have to charge my phone meanwhile. Let me tend to that real quick. Bum, bum, bum. Also, let me just put this up a bit like that. Cool. You can see. Let me go back to the stream thing. I just keep liking to like watch Leanie out there. It's like a little figurine out there reading her book. Ah, there we go. Still seated comfortably. Where about ish right there. It's hard to tell. Yeah, we're making the most of the good weather out here. At least Leanie is. Like I'm seated indoors doing a stream, so life decisions, huh? I'm not as successful in always making the right call as Leanie is. Definitely not. All right, cool, cool, cool. So what were we doing? 7, here we go. Let's do the resource thing. But then we have to, oh no, that's right. Resource. Notes, resource. Okay. Next project in it. Okay. The structure of the repo, I don't think is very optimal all the time. We close the assets, go back to init. We have these definitions. What do we need now? Oh, we already have. Oh, that's from schedules. Okay, resources. Cool. All right, schedules and resources. Actually, it's interesting. Assets, schedules, and resources. Those are the primitives we've learned about thus far. So assets, schedule, and resources. Let me. Come on. Resource. Okay. And then All right, so let's build that intuition. Resources. It's weird. So load assets from modules. I don't know what a signature is of the thing that comes out. I'm guessing it's a list. Then schedules is a list. Then resources is an object. Key value, whatever, because we probably refer to these resources by this shorthand name. GitHub, right? OS environ. Yeah, well, actually, we don't even have to do it because, yeah, you know, let's do it right away. OS.environ. GitHub token. In our case, double check that this is correct. Fine. Lines. And that. OS environment, this thing needs to import OS. Well, I actually don't know what it is. It doesn't know GitHub either. So what we're going to do is we're going to go into init from GitHub import. I copy pasted inside of you. Whatever. From GitHub import. GitHub. Fine. So the GitHub API is just an instance of the client. Fine. Is there anything we still need to? I think it's fine. We use the resources argument of definitions to provide resources. To get the name GitHub API is called a resource key. And how our assets can reference the resource, we provide the access token. The environment variable, we already had that. We skip over this. Look for this file. Oh, the easiest way is to get a .env file in the environment. Oh, goodness. Awesome. And so the environment variables for you, it's important to avoid checking any out. We know that if you're using Dagster Cloud, you can provide secrets via the Dagster Cloud UI. If you develop development guides, you can see the deployment guides for how to set environment variables. Use the resource from our assets. All right, so now we need to go into our assets in it. And then GitHub Stargazers doesn't need to do this anymore. We can drop, so first of all, we can drop this. I believe the only place where we needed this information was where we called GitHub. What's the issue? Okay, let's just use the Vim bindings. I think we don't need. Do we? We do actually. We use it here. GitHub access token, but we're going to replace all of these with a resource. So here, this thing here probably becomes the resource. Oh, this is cool. Cool. So, okay, we just do some code examples in Python. Up asset and f name asset context depths optional up nope and this so and maybe we can do this here up. Okay, cool. I have this noted here. Fine. Assets can depend on other assets. Assets can refer to context. Wrong. Contains environmental element data like resources, etc. Logger Environment facilities. Okay, cool. More than enough. And BG, put this in background. You don't need to think about that now. Okay. All right. So how we access this thing? Let's say, well, now the Stargazers gets caught. Jeez, I'm really not happy about dim, dim mode. Let me disable mine. Is it disabled? Oh, Vimium. What the hell? I fucking hate this. We should be able to just flip it off for a particular tab. Pin, and if I click it, Vimeo will be disabled. And if I click it again, okay. What if I do this? Okay, cool. If I do this and this, it's still fucking there. Okay, or context, and then we get this from context and resources.github API get repo blah blah blah. We do the same thing at the bottom, obviously, where we already have context. So we say context.resources.github API. Go. Clean, 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 clean. Long line. Get user, get gist. Maybe it fits on a single line. Who cares? Who cares? All right, rerun the job. Okay. OS, I don't need OS. Drop it, drop it. Good. Now I need to tag it. Daggett is the whatever. It's not a UI. That's kind of like UI console slash dev tool. Dev tool. All right. Adding some tests. There we go. This is the good part. The good part. Now it's time to add some tests. Open up test. Let's have a look. What does this look like? Init blank. So much boilerplate sometimes in Python code bases with init files and the PyC files, which of course they need to be there, but it's kind of like distracting sometimes. All right, materialize to memory. Okay, it's a whole test case. Oh, learning more. We're almost done. We're almost done. All right, cool. So let's do this. Motivation from Dagster. Import materialize to memory. Isn't that always where we materialize to? I think that's default. I think it's curious if we had to specify this. Okay, unit test.mock import magic mock. I love this toolbox. My Dagster even thought about testing project.assets. Import. Come on. What are we importing? All of my Stargazers. We start with that, right? And then we had GitHub Stargazers by week. That's the next one we had. Then GitHub Stars Notebook, which I don't think is a great name. GitHub Stars Notebook. Or maybe it is actually, because it just materializes that asset. Serializing this asset stargazers. Serializing this asset stargazers by week. Then the notebook, and then the notebook gist. Fair enough. Doesn't have to. You don't have to include verbs in those names. In asset names, because an asset is not a verb. It's just outcome. So we need date and date time for some reason. Import pandas SPD. All right, let's see. Def test smoke. We can run this right away. And then we say mock stargazers. That's why we needed the date time thingy. User one, tuple, date time 2021. Oh shit, was this thing written 2021? Can imagine that the API is out of date then. Probably was. User 2, date time 2021. However, 1 again. And then user 3, date time. I could see her. Beanie. I'm waving at her. Once in a while, she looks up, and then if I spot her, then I can wave at her. That's funny. I don't know. We find it funny. We're not good in the head. I know that. All right. What we're doing, daytime 2021, 2-1. Yeah, I'm sometimes like an adult. Almost like an adult child. It's not super helpful, I guess. GitHub API magic mock. So thinking for the discovery. Underscore test. So PyTest would probably find it, right? GitHub API get repo Daxter IO Daxter. Okay, so we're specifying get. This is already feeling like a lot more work than we want to do. Test smoke. Why is test smoke so heavy? We have mock stargazers. Return value. Huh. Where does login come from? Something is missing. Let's go here. Let's try to pay attention. We define this mock data set of basically stargazers. Then with magic mock, we get repo, get stargazers with dates, return value, we set that. It's magic mock user, magic mock login is login. Where the fuck does login come from? Ah, here, for login started in mock stargazers. Okay, so that's how we use it. Fair enough. All right, show can go on. Sometimes you need to read on. Yeah, so I guess what we're doing really. So we're going to mock this API call. Get stargazers with dates. Return. Come on. Value is this thing is going to be composed by iterating over stargazers. Let me just type that out. There's some cleaning going on outside, folks. Yeah, there's always something going on. And this thing here, magic mock we go. User is magic mock. We know where this comes from now. Login is login. That's just one of these initial fields. And then what we are getting back is start at, which is going to be the start at date. And second number of the tuple that of our little dummy tuple. Of course, I shouldn't try to drag things around. So now Magic Mock is also like kind of like what monkey patching this thing. So anything we do with GitHub API is going to be heavily yesed by the mocker. Create gist, return value. We're just basically mocking all the calls where we'll probably that we will be hitting with the different assets that we've written. Just to github.com/test ID. So this is what we're going to get after create gist. Create gist. Why do I say gist? And result. We're going to materialize to mem. Right, and then what does this do? I wonder what this does. It does actually. GitHub stars notebook gist GitHub stars notebook is ordering relevant. GitHub stargazers by week. GitHub stargazer. There seems to be an order here, which I didn't have. Like this, it doesn't matter here for import, but for this one, I could figure order is relevant. Well, we could flip it around in a minute, see what happens. Experiment with order. Yeah, should work. Sources. Come on. GitHub API. GitHub API. So now we've passed along the stubbed or the mocked GitHub API. All right, so now we can run assertions. Assert. That's cool. Materials to memory. Okay, so this is order dependent. I would bet it is because we materialize these things to memory. Stars notebook gives notebook by week stargazers. We could probably start here at the end and work our way up, which is weird. Maybe we could also just always grab head and then you basically recurse down tail. Anyways, not time to overthink. We can play around with it in a second. Assert result success, assert result output for node. Boop, boop, boop. So what's the node? GitHub stargazers by week. We're trying to see here. Reset index. I'm guessing on that. Predict records. So what do we do here? We verify it's equal to the structure. The index resetting. I don't understand. Maybe we look that up. I like to look things up. Reset index, and I think it's pandas. I may be wrong. What's pandas? So pandas, tell me, what does it do again? Is data from its multi-index can remove one or more levels or a level of it. Okay, fair enough. Cool. Snap. Yeah, because you can do like funky indexes and pandas. As you can see, they did like word indices, but you want to reset it and then it's just is it columns class and max speed? So you have class and max speed. That's the index we have there. Okay, reset sequential. What if? Okay, that's okay. That's okay. I think we get it now. Let's write the dummy values. Let's write them out. Users to TV. The truckers are having a hard time. They're stuck in the ice. So the week is going to be date of 2021, 1/3. Yep. And users. 1 week date. All right, fair enough. It just bind things together. Cool. So this is okay. We got this, and then we can actually run. You don't need to run all of this. What if we just test syntax error? Fair enough. Test again. Okay, resources. What did I do wrong? Line 15. Weird. My extra project. I close this. Look at init. Then, of course, that was just unnecessarily. It's such a great editor. Why doesn't it tell me these things? Huh? Should have kind of like. All right, so failed. Why? Probably better if I read it fully. Param resources is not one of mapping. Got GitHub API, blah, blah, which is typeset, blah, blah, blah. All right, so we made a mistake in mocking our junk. Weird. Immaterialize the memory. Double check. Let's see what is going on here. Basically, our test, yeah. And then what are we looking at here? Materialize the mem. We have a list. Then we have resources. Yeah, come on. Object. Predict. It's weird that this editor doesn't complain. All right, next error. Okay, this is a large block. Unknown resource, GitHub API. Which is weird because I do. Where something is in memory manager. Huh. this is none of this is the issue apparently, and none of this is lazy, as far as I can tell. So things should have broken there already. But it's during this call that things fell, and it is for which reason? Uh, huh. Context resources, GitHub API. Get me to the init. GitHub API, GitHub OS environment, GitHub token. Looking fine. Materialize the memory. Okay, maybe we just check out materialize to memory Baxter. See if it's a change. New docs probably have the authoritative way to deal with this. Assets, run config, instance, resources, none. All right, so resources, optional mapping string to object. All right. Can provide resource instances directly or resource definitions. Huh. If provide a resource conflict with resource directly on assets, there will be thrown. Is that the situation? Huh. Yeah. You think that copy pasting this entire block would run? Let's give it a shot. Can I comment all the code in one go? Edit, toggle line comment. Cool. Then I drop this below. Retry. Retry. Come on. Editor, clipboard. Okay, here we go. Retry. It's just being lazy now. Nope, doesn't work. Why is there this weird indentation issue? Crap. Yeah, come on. That's just poor. All right. There are a lot of errors in this article. Not a lot of errors, there are a bunch of issues in the article. And why does this thing fail? Same errors. Unknown resource GitHub API. Specify GitHub API as a required resource on the compute config function that accessed it. So, and it accessed it. Let's just look for this error message. And that didn't work. Let's do here. Resource computer. Gosh, this is not ideal. All right, here we go. On the compute/config that function that accessed it. All right, testing. Cool. I think this is it for today. We more or less got most of this. We built a pipeline, so like just go to dag it, go back to see what we did. We basically follows the blog post to build a pipeline that produced this Python notebook, which kind of like came from here. You can kind of look at it here. Close, reload this thing. Look. Jobs, you can see we have a daily refresh job in there, and it's never materialized because this was in memory. It's not in memory anymore because we just started DAG it again. But it's a job, it's a pipeline. It gets the stargazers, then it kind of like computes stargazers by week, then it produces some notebook representation, and then it writes that notebook into a gist, which is, I believe, this thing. So I guess for one streaming session, we can call this relative success. We got this to kind of like work. And my freaking screen wasn't shared anymore. Gosh, am I a fucking idiot? Yeah. Didn't do this right, and I didn't notice any messages or something. There weren't any, so that's all good. Anyways, we figured out the Dagster thingy. I'm just going to show you towards the end. Pipeline, there you go. This is a pipeline. This pipeline produces this file somewhere on GitHub. It's a gist. That's it. And of this lousy streaming episode. Excuse me for being such an amateur. It still happens, eh? It still happens. I got to figure out how to eliminate some of this. Sometimes I move out from the screen sharing and then I put the camera on because I'm typing in some secrets or whatever. And then for some reason, I just forget. But I'm guessing as long as the audience isn't complaining about it, then it's probably not the biggest pain. So I figured you weren't completely disturbed by this. Thanks for being here and checking this out. Let me see if I can actually get a sense of what's happening on the Twitch side of things. That doesn't work on the Twitch side of things. All right. Anyways, I'm going to be playing around with more of this Dagster stuff later. Probably going to figure out what the bug is, if I still feel so inclined. Or I'm probably just going to try to write tests from scratch using the documentation instead, since I feel like this article is a bit outdated. But I think we can all kind of slowly but surely start to imagine how we could design Dagster pipelines to do a variety of different things. So not too bad. Talk soon, y'all. Y'all take care. Be kind to each other. Ciao, ciao, ciao.